Assalamu alaikum. Today we will talk about how to print a character or a string using assembly language. Again, your application, okay, this is the application side. You need to print something on the VGA. So again, I'm going to use the help of the operating system. Calling the operating system will write or print the character or the string on the VGA. How to call it? Using interrupt 21 again. So interrupt 21 will help me in this one. Which function? There are two functions that help you to print to the VGA. Function AH equal 2 will print single character. Okay, whereas AH equal to 9 will print a string. The question is now, the character here that will be printed, where is it? It will be located in DL. How about the string? The string is not a single byte. It is an array of bytes, string of bytes. So if you need to print a string of bytes, that means you need an address of that string. So the address of that string is located in DX. You see, here single character, and here is the address of the string. This way, I can print on the VGA using the operating system. There is another way, I will talk about it later, that you can directly write to the VGA as a memory location, because I know that the VGA area is located at B8000 hex. So if I manage to write directly to this area, that means I'm writing on the VGA. Okay, so let's take an example and demonstrate how we can write on the VGA. Okay, before proceeding and writing an example about how to print a single character or a string, let's just read about interrupt 21 function 2 is about write character to standard output. The character that to be print is located in DL, okay, DL. You see that after execution, AL is equal to DL. That helps you to know what character has been print if you need to read AL. So move AH comma 2, this is an example. The character to be print is A, so you locate the ASCII code of A into DL and then print on the screen. Whereas if you want to print a string, you move to function 9. Function 9 output a string. The data or the location of that string is located in DX. So DX should contain the address of the string to be printed, and you should end or terminate the string by the $sign. $sign is, let's say, is a signal to the system. You should end the printing on the VGA. If you don't locate $sign, the system keep printing all the memory till it's find the $sign. So you have to be careful. If you don't use $sign to terminate the string, things will be printed on the VGA you don't want. Okay, for example, see here, move DX is offset of message. Offset of message is located here. Message is defined by hello world and ended by $sign. Move AH comma 9, interrupt 21, and you will get your answer. So let's start here. For example, I defined my name defined by hello and terminated by the $sign. Of course, you can write $sign as part of the text. Okay, the $sign won't be printed here. Okay, let's start to print a single character. Okay, to print a single character. So move DL comma. If you want to print, for example, Y, just the ASCII code, Y small, Y capital is different. Move AH comma 2, interrupt 21 hex. If we run this code step by step, oh, I have an error. Sorry, I forgot to delete this old code. Okay, I'm fine now. Okay, so step by step. Now, DL, please watch DL. It will contain the ASCII code of Y small, which is 79 hex. No need to remember the ASCII code of each character, alphabet, or number. You just place it in quotation, and the compiler will do the job for you. So, interrupt AH, comma 2, interrupt 21. Now, the black screen will pop up and Y on the corner here, okay? And this is it. Next, if you want to print more than one character, for example, let's make a loop, okay? So move CX, comma, I to print 10 characters, okay? L1, okay? And assume I want to print A, B, C, D, so just locate A here and increment DL, loop L1, and L1 is here. Let's read this one. Move CX, comma 10, printing 10 times. Move DL, comma A. So DL will contain 61, which is the ASCII code of A small. And printing on the screen. Next, increment DL. That means 61 will become 62, the ASCII code of B, and loop again to print again and print again. Let's run this code and see what will happen. Okay, so 61 in DL, AH2, interrupt 21. Okay, this is A. Next, increment DL. Now DL will be 62. Print 62, you will have B and C and D. So I can print all the characters using just incrementing their values. Very simple, okay? No need to bother yourself to print every character using its ASCII code. You just, the first ASCII code and then increments by 1, by 2, for example, whatever you want, okay? Of course, CX, now N, this is the N, so I'm printing from A to J, okay? If you want to print all the ASCII code characters, okay, and here we start with 0, and then you can print them all, as you can see. Run. Notice CX, notice DL, DL is incrementing, CX is decrementing, instruction pointer updated by itself, and all the ASCII code table is here, okay? How about if we want to print my name? So I will delete all of this, okay? Move AH, comma 9, interrupt 21 hex. Now, before running interrupt 21 hex, move AH9, I have to initialize DX. So DX should contain the address of my name. So load effective address, DX, comma, my name. Okay, or you can write move DX, comma, offset my name. Same. Okay, let's see what's going on. Emulate, single step. Now dx contains, you see, dx contains the address of my name, which is 0 for the moment. AH is 9, enter 21, and hello, done. Okay. For example, if you want more words, okay, I love PSUT. It is an amazing university. Okay, do it again. Okay. How about if you forgot to include the sign? No one will warn you or notify you. Okay, when you do emulation, nothing will happen. But when you run it, okay, you see, enter 21, function 9, address 7100, byte 24, the $sign, okay, not found after 2000 bytes. So it searched for 2000 bytes, not finding 24, which is the $sign, so it gave you this warning and stop, because it can't print all the memory in front of you, okay? So be careful to include the $sign in your text. Good day.